Hello everyone. Our lesson today is lesson 4 in unit 5, the cyclic quadrilateral and its properties. If we have 4 points like A, B, C, D, and these 4 points lies on the circle, we called A, B, C, D is a cyclic quad. So here, if we have 4 points lies on the circle, so the quadrilateral here is called cyclic quad. So the cyclic quad is a quadrilateral whose 4 vertices lies on the circle, and we can draw a unique circle passing through these 4 vertices. We have some properties of a cyclic quad. Number 1, each two opposite angles are supplementary. It means here measure of angle A plus measure of angle C, its opposite, the sum of them is 180. And also measure of angle B plus measure of angle D also will be 180. And the sum, as we said, of any quadrilateral, the sum of interior angles of any quadrilateral is 360. So the first property here is each two opposite angles are supplementary. Their sum is 180. The second one, the measure of the exterior angle at any vertex equal the measure of the interior angle opposite to its adjacent. Here is the exterior angle and here is its adjacent. So here we have the measure of the exterior angle equal to the opposite of its adjacent, which is measure of angle A. So here measure of angle DCE equals measure of angle A. The third one, each two angles are drawn on one side of each side as one base here are equal in measure. It means if we call here angle 1 and angle 2, measure of angle 1 equals measure of angle 2. And these two angles drawn in one base, which is BC. And also if we said here measure of angle 3 equals what? Measure of angle 4, and this base is AD, and also we have measure of angle 3 equals measure of angle 4, and also measure of angle 5 equals measure of angle 6, measure of angle 7 equals measure of angle 8. Okay, the last one, if we have a point in its plane like M here is at equal distance from its vertices. It means here MA equals MB equals MC equals MD. So here we have MA equals MC equals MB equals MD. Here we have the 4 properties of a cyclic quad. And when we want to prove that any quadrilateral is a cyclic quad, we prove that one of these properties. To prove that the quadrilateral is a cyclic quad, we must prove that one of these properties. We have some examples. Number 1, we have here angle A is 80 degree, angle C is 50 degree, AD equals AB, and we want to prove that A, B, C, and D have one circle passing through them. It means we want to prove that ABCD is a cyclic quad. Okay, as we said here, cyclic quad is a quadrilateral whose 4 vertices belongs to the circle. So it means here we want to prove that ABCD is a cyclic quad. So we want to prove one of its properties, as we said. Here in the triangle ABD, we have here angle A is 80 degree, and here is an isosceles triangle. So measure of angle ADB equals measure of angle ABD. equals 180 minus 80 divided 2. It means here measure of angle D 50 and here 50 degree. What did you notice here? Here angle ADB equals angle ACB equals 50 degree, and they're from one side and have one base which is AB. So ABCD is a cyclic quad. Okay, let's write it. First, since AD equals to AB and measure of angle A is 80 degree, so we have here measure of angle A BD equals measure of angle ADB equals 180 minus 80 divided 2, which is 50 degree. So measure of angle D is 50 degree. Since measure of angle D equals measure of angle C equals 50 degree, don't forget to write the reason here drawn on AB and on one side of it. Okay, so A, B, C, D have one circle passing through them. Or ABCD is a cyclic quad. The second example, we have here measure of angle B 100, measure of angle BDA is 30 degree, and another given sine angle ACB is half. What the meaning of sine ACB is half? It means here since sine angle ACB equals half, we studied in the previous term how to get the measure of the angle by shift sign. It means sine minus 1 half. So we get measure of angle ACB equals 30 degree. Here measure of angle ACB. Okay, what did you notice here? Here measure of angle ACB equals measure of angle BDA, okay, drawn on AB and on one side of it. So here we have ABCD is a cyclic quad. So here since measure of angle ACB equals measure of angle BDA equals 30 degree. Don't forget to write the reason here, the two angles drawn on AB and on one side of it. So ABCD is a cyclic quad. The second required, we want to find measure of angle BDC. BDC here, we want to get this angle. How? As we said, from the properties of the cyclic quad, each two opposite angles are supplementary. So the sum of measure B and the sum of all D is 180. So to get measure of angle BDC is 180 minus 100 plus 30. It will be 50. Or another method, here in the triangle ABC, we have here B 100 and C is 30. So here measure of angle BAC is 50 degree. And also from the properties of the cyclic quad, here measure BAC equals measure of angle BDC. Why? They drawn on BC and on one side of it. Okay, using any method. So here from the properties of the cyclic quad, ABCD, we get measure of angle B plus measure of angle D is 180. So measure of angle BDC equals 180 minus 100 plus 30 equals 50 degrees. Another example, we have here quad ABCD. Here measure of angle B 110, measure of angle B DC is 360 degrees, measure of angle B CF is 34. We want to prove that, or is ABCD is a cyclic quad or not. So we want to prove one of its properties. If the property satisfies, so the ABCD is a cyclic quad. If it's not satisfied, so it's not a cyclic quad. So here we have in the triangle ABC, we have two angles. So we want to get the third one equals what? 180 minus 110 plus 34. So here, since in the triangle ABC, we have here measure of angle B is 110, and also measure of angle B CA equals 34 degree. So measure of angle B AC equals 180 degree minus 110 plus 34. It will be 36 degrees. So what did you notice here? Here we have 36 degree, and also we have here 36 degrees. And the two angles are drawn on BC and on one side of it. So the quad here is called a cyclic quad. So here, since measure of angle B AC equals measure of angle B DC equals 36 degree. And don't forget to write the reason. They are drawn on BC and on one side of it. So yes, ABCD is a cyclic quad. Thank you.